Have you wondered why some constants are used in mathematics and science? The constants used in mathematics and other aspects of science are usually gotten from experimental procedures, not assumed. The Archimedes constant, popularly known as pi, is one of the oldest of the mathematical formula, and it is concerned with the formula for calculation of circular objects. It was observed that any circular object, when you go through the periphery, that is the circumference, and divide the circumference of that particular circular object by the diameter, you will always get a constant, irrespective of what object and size of the object. As far as you obey the circumference and the diameter of the same circular object, you get a number, and that number is what we call pi. Let's consider the circular object here, the metallic circular object. The circumference, remember, is the distance round a circle, is also called the perimeter, and dividing it by the diameter of this, you will get a constant. Whenever you divide the circumference of a circular object or a circle by the diameter of the same circle, you always have a constant, and that is the Archimedes constant. For here, the circumference is 47.13. Automatically, the diameter have to be 15 cm. Such that for you to find the pi, if you divide 47.13 by 15, you will get a number known as pi. So let us experimentally determine the value of pi. What I need here, I'm using the screw gauge, is not the real gauge, then the circular object. Rather, I use the screw clamp. Then I have a pipe. Then I have a reagent bottle. I want to get the diameter. I want to use these objects to confirm if the value of the so-called mathematical constant is true. Let's determine why we use that value for pi that we use in mathematics. As you can see now, I have to determine the diameter of this circular object. For my metal rule, it is reading 15 cm. That's the diameter of the first object I'm trying to use to determine the mathematical constant. So I have to record it in the order 15 cm. Then let me now determine the circumference by using a thread. Also, you can equally measure direct. If your ruler can pass through the center of the circle, it is still showing 15 cm, the external diameter. Then I want to determine the perimeter, that's the circumference of the same object, and relate the ratio of the circumference of this with the diameter of the same object.
So here is 48.5. I hope the camera can get that. I have 48.5. Here is 1. Here is 1. So I will. It is supposed to be 48.4. Please, yeah. See, little error. 48.4 minus 1.
On the average, although I did my initial 1, that should be 48, then minus 1 will give you 47.4. Now, taking the ratio of 47.4 all over 15, I'll have automatically 3.16. You see, I'm not very far from it. Now, let's see this reagent bottle. I have to use the same procedure. I'm determining the diameter now. From my metal rule, this reads exactly
here is 10
cm. That's the diameter of this reagent bottle. So I have to record it. Then come and take the perimeter. The perimeter here, using the metal rule, this is 32 minus 1.
So that means the circumference is 31. 32 minus 1 is
0. I started from 1 as my initial
cm.
Then I have to record. Then I did the same thing with this pipe. I discovered that the smaller the size of the object, the further away I am from the answer. Therefore, I have to take the average of the two I got first, which is 3.16 plus 3.10.
3.13. Then, what is actually the value of pi? The value of pi is, I estimated or approximated to be 22 over 7. Not that it is exactly 22 over 7, because it is an irrational number. So, if you look at this relation here, which tells us that circumference is 2 pi, circumference of a circle is 2 pi, that means 2 pi by radius, 2 pi times radius. In that case, if you do the subject of the formula, at the end you cancel out, you now see that pi is gotten by circumference over diameter.